Okay, in this tutorial I'm going to help you account for the differences in the discharge between a rural and an urban hydrograph. Now in this question we cannot rely on explaining the rainfall changes which are shown in the bars, because actually we've got the same rainfall, we just happen to have two very different hydrographs. So what we're really saying is the same amount of water is falling on the drainage basin of two different rivers. So why, and this is the key to this question, why does River A, what we would call an urban river, rise to such a high peak compared to River B? Also, why is the lag time of A very short, whereas the lag time of River B is actually very long? What that really means is the water takes a long time to get to the river in the case of River B, but in River A the water gets there really quickly, and also in River A all of the water that falls out of the sky gets to the river, whereas in River B only some of it does. Okay, so there are lots of reasons for the differences, and you can compare and contrast the two, or you can just deal with why is A doing what it does and then why does B, and I'll go with the second approach to answering that. Why does A do what it does, and then why does B do what it does? Okay, so River A has a high peak compared to B. The reason for this is River A is flowing through a city. And what this means is the city has no natural stores of water. So in a city, most of the vegetation and trees have been removed, which would have absorbed quite a lot of the water as it got intercepted by the leaves of the plants and then absorbed by their roots, and it would have been held by the plants. Now cities obviously don't have much in the way of trees, and therefore there's very little of that going on. Cities also don't have things like lakes that might store a lot of the water for a long period of time. Cities are also covered in tarmac. Now that means that the water, instead of absorbing slowly into the soil in a process known as infiltration, and then soaking into the rock in a process known as percolation, all of the water is just flowing across the tarmac surfaces into drains and then directly to the river. Okay, that's also why there is a short lag time. There's a short lag time in this particular diagram because the water's being directed by drainage systems of cities to the river very quickly. Okay, now let's have a look at River B. River B's a bit different. River B has a much lower peak and it's got a much longer lag time. So why this lower peak and this longer lag time? Well, it's probably because it's in a rural area. And what that means is it's in the countryside. So first of all, there's going to be a lot of vegetation, which will absorb a lot of the rainwater that falls out of the sky, and that water will be retained by the plants, and it will never get into the river, and that explains the lower peak. Okay. Also, because the water is being intercepted by vegetation, it's not going quickly to the river, and that's also a reason why it's much slower arriving. Also in the countryside though, you've got lots of exposed grass fields and crops growing, and therefore the water's falling on that. It's being absorbed by the soils, it's being infiltrated into soils and stored in the soils, it's percolating into the rocks and it's getting stored in the rocks, and it's therefore taking a lot longer to transfer into the main river. You might have a lot of other natural stores in a rural area. You might have some lochs, for example, that will hold on to a lot of the water as well. Okay, so those are the key reasons for the differences between our two graphs, our urban and our rural. And A, just to remind you, that is our urban, and B would be regarded as our rural hydrograph.